All right, so you want to understand information hiding better in software design, right? You sent over some excerpts from Texto Pagado that lay it all out, and I'm excited to dive into it with you. We'll go way beyond defining it. We want to see why it matters and how it can honestly make your code seriously better.
Yeah, it's more than just a neat trick,
Yeah.
like it's a whole philosophy that can really elevate your code quality.
Exactly. Imagine you're working on a project, maybe like a complex web app, and you need to update some critical piece of code, but every time you tweak something, totally unrelated parts start breaking. It's
Oh, yeah,
frustrating, right?
absolutely. That's like a classic symptom of bad information hiding. When the internal details of your code are just out there exposed, it creates this ripple effect where changes can just cascade through the entire system, kind of like like a house of cards. You pull the wrong one and the whole thing just collapses.
Okay, I see the danger there. So how does information hiding help us avoid these code catastrophes?
So basically, information hiding is about creating boundaries in your code, strategically concealing the internal workings of modules and classes, exposing only what's absolutely necessary through well-defined interfaces.
Okay, I get the hiding part, but what's the big deal about these interfaces?
Think of an interface like a contract. It specifies how other parts of the code can interact with a module or class without needing to know all the messy details of how things work under the hood. Like, think about using a car. You don't need to know about the engine or the transmission to drive it. You interact with the steering wheel, pedals, and gear shift.
So it's about simplifying the interaction between different parts of the code.
Yeah, precisely. By limiting what's exposed, we reduce complexity and make it easier to reason about the system as a whole. It's like packing for a trip. Imagine throwing everything in your suitcase haphazardly. It'd be a nightmare to find anything. But if you organize your belongings into compartments, each with a specific purpose, packing becomes a breeze.
Right. Everything has its place. You don't have socks with your toothbrush. So information hiding is like creating compartments in our code.
Exactly. We're encapsulating information and functionality into self-contained units, making our code way more modular and manageable.
This is making a lot of sense. But Texto Pagado mentions other benefits like reduced complexity and improved modularity. Can you break those down a bit more?
Sure. Let's start with complexity. As software projects grow, they obviously become more intricate and interconnected. Information hiding helps us manage this complexity by breaking down the system into smaller, more manageable pieces. Each module or class has a specific responsibility, and the details of how it's implemented are hidden. This makes it easier to understand individual components without getting bogged down in the entire system.
It's like tackling a giant jigsaw puzzle. It's
Yeah.
much easier if you focus on smaller sections first, right?
Yeah, that's a great analogy. And this leads us to modularity. By encapsulating information and defining clear interfaces, we're essentially creating these reusable building blocks that can be combined and rearranged to create more complex systems. Think of it like Lego bricks. Each brick has a specific shape and function, and you can connect them in tons of ways to build all sorts of structures.
So instead of having this monolithic, tightly coupled code base, we get a more flexible system made up of independent, interchangeable modules.
You got it. And that flexibility is crucial for long-term maintainability. Because the internal details of a module are hidden, we can modify or update them without affecting the rest of the system, as long as we don't change the public interface. It's like swapping out the engine of a car. The driver still interacts with it the same way, even though the underlying mechanics might be totally different.
Okay, I'm really starting to grasp how this all fits together. So less complexity, more modularity, easier maintenance.
Yeah.
What else?
Well, one of the biggest payoffs of information hiding is improved testability. Because we have these well-defined modules with clear interfaces, we can test each one independently, making sure it behaves as expected before integrating it with the rest of the system.
That's a huge win. It's much easier to track down bugs in a small, isolated module than in a giant, interconnected mess of code.
Absolutely. It's like testing each ingredient in a recipe before baking the cake. You catch any issues early on and avoid a culinary disaster.
Can't argue with that analogy. Now, this all sounds great in theory, but I'm eager to see how it plays out in practice. Textobagado includes a Python example using file I/O. Do you think walking through that would be helpful?
I think it would be incredibly illuminating. Let's jump into that.
All right, let's take a look. So in this example, we've got a Python class called FileReader. It's designed to read files, like the name suggests. The source shows some before code where the information hiding principle hasn't been applied yet. What stands out to you about this initial code? What are the potential pitfalls?
Well, right off the bat, You can see that the internal details of the file reader class, like the file path and the file object itself, are exposed. They're directly accessible from outside the class, which is a big no-no from an information hiding perspective.
It's like leaving the blueprint of your house out in the open for anyone to see, right? Not exactly the best security practice.
Exactly. It makes the code vulnerable to unintended modifications and increases the risk of errors. It also tightly couples the internal workings of the class to the rest of the code base, making it harder to change or maintain in the future.
That makes a lot of sense. So how does the after code address these issues?
Well, in the updated code, we see that those internal details, the file path and file object, are now marked as private attributes. Python uses double underscores to achieve this, basically telling other parts of the code, hands off. These are for internal use only.
I see. So it's like building a fence around those sensitive parts of the code.
Precisely. And to interact with the file reader class, we now have a well-defined public interface using methods like open, read, and close. This is how other parts of the system should interact with the class, rather than directly accessing those private attributes.
So instead of barging into the house through any open window, you're now politely using the front door.
Exactly. It's a much more controlled and predictable way to interact with the class.
So this is making the code much more secure and robust, right?
Absolutely. And the beauty of this approach is that we can change the internal implementation of the file reader class without breaking any code that uses it. As long as we keep those public methods, the open, read, and close functions the same, the outside world doesn't need to know what's going on behind the scenes.
It's like renovating the inside of your house. You can rearrange the furniture, paint the walls, even knock down a few walls, but as long as the front door remains the same, your guests can still come and go without getting lost.
That's a fantastic way to put it. And this flexibility is incredibly valuable as software projects grow and evolve. Requirements change, new technologies emerge, and you need to be able to adapt your code without causing a domino effect of errors.
So information hiding is like future-proofing our code in a way.
Precisely. It allows us to make changes with confidence, knowing that we're less likely to introduce unintended side effects. And this ties back to what we discussed earlier about testability. With information hiding, we can write focused tests for each public method, ensuring they behave as expected, regardless of any internal changes.
Right, so not only does it make our code more robust and flexible, but it also simplifies the testing process. It's a win-win. Now, I know we've been focusing on object-oriented programming with this Python example, but Textopagado emphasizes that information hiding is not limited to just one programming paradigm. It mentions applications in functional and modular programming as well. Can you shed some light on how that works?
Absolutely. The fundamental principles of information hiding remain consistent across different programming paradigms. It's all about controlling access to information and minimizing dependencies between different parts of the code.
So how does that play out in functional programming, for example?
In functional programming, functions are like the primary building blocks. Information hiding is often achieved through careful design of function signatures and techniques like closures. For instance, imagine you have a function that calculates the total price of items in a shopping cart. You might pass the cart data as an argument to this function. Now, the internal details of how the cart data is structured or stored are irrelevant to the function itself. All it cares about is receiving the necessary data to perform the calculation and returning the total price.
So the inner workings of the shopping cart are hidden from the pricing function.
Exactly. The function only sees what it needs to see, defined by its input parameters. And closures can play a role here as well. A closure allows a function to retain access to variables from its surrounding scope, even after the outer function is finished executing. This can be used to create private data that's accessible only within a specific function or group of functions. It's like having a secret ingredient in your recipe that only the chef knows about.
Okay, that's a great way to visualize it. Now, what about modular programming? How does information hiding work in that context?
In modular programming, code is organized into distinct modules, each with a specific purpose. Information hiding is achieved by defining clear module interfaces that specify what functions, classes, or data are exposed to other modules. Internal implementation details are kept hidden within the module itself. For instance, you might have a module responsible for handling user authentication. This module might expose functions like login and logout, but the underlying mechanisms for verifying user credentials, storing passwords, and managing sessions would be hidden within the module.
So it's similar to the object-oriented approach, just at a higher level of granularity.
Exactly. Whether it's classes, functions, or modules, the principle remains the same. Control access to information, and minimize dependencies to make your code more modular, flexible, and maintainable.
This is fascinating. It really highlights the depth and breadth of the information hiding principle. Now, you mentioned earlier that different programming languages provide different mechanisms for implementing these concepts. Can you elaborate on that a bit?
Of course, while the underlying principles are universal, the specific tools and techniques for implementing information hiding can vary depending on the programming language you're using. For example, Python uses double underscores for private attributes, as we saw in the file IO example. But other languages like Java, C++N, and C# use access modifiers like public, private, and protected to control the visibility of class members.
So it's almost like each language has its own dialect for expressing these ideas.
That's a great way to think about it.
Yeah.
And even within a specific paradigm, like object-oriented programming, there can be subtle differences in how various languages approach encapsulation and information hiding. Understanding these nuances is key to applying the principle effectively in your chosen language.
That makes a lot of sense. It's like learning the local customs when traveling to a new country. You need to know the right way to greet people, order food, and navigate social interactions. So for our listeners who are eager to put information hiding into practice, would you recommend they dive into the specifics of how their preferred language handles it?
Absolutely. Familiarizing yourself with the tools and techniques your language provides will empower you to write cleaner, more maintainable code. Textopagado touches on this briefly, encouraging readers to explore further based on their chosen languages.
Excellent advice. Now, so far we've been talking about information hiding solely in the context of code. But I remember Textopagado hinting at broader applications. It suggested that information hiding principles can be applied to design and architectural decisions as well. That's really intriguing. Can you give us an example of what that might look like?
Certainly. Imagine you're designing a system with multiple components that need to communicate with each other. You could apply information hiding by defining clear interfaces between these components, specifying how they should interact without revealing the internal details of their implementation. For instance, let's say you're building an e-commerce platform. You might have separate components for handling user accounts, product catalogs, shopping carts, and payment processing. By defining clear interfaces between these components, you can decouple them, making the system more modular and easier to maintain.
So instead of each component needing to know the inner workings of all the others, they just need to know how to send and receive messages through these well-defined interfaces.
Exactly. This reduces dependencies and allows you to modify or replace components without causing a ripple effect through the entire system. Changes to the user account component, for example, wouldn't necessarily impact the payment processing component as long as the interface between them remains consistent.
That's amazing. It's like having different departments in a company. Each department has its own responsibilities and expertise, and they communicate through well-defined channels without needing to know the intricate details of how other departments operate.
That's a great analogy. And this approach can be applied at various levels of system design, from the interactions between individual modules to the communication between microservices in a distributed architecture.
Wow, this has been a real eye-opener. It's amazing how these principles can be applied at so many different levels, from individual lines of code to like the overall architecture of a system.
It really shows the power of good design principles. They go beyond specific languages or paradigms and give you a framework for building robust and maintainable software.
When we started talking about information hiding, I thought it was mainly about keeping things neat and tidy, but now I see it's about so much more than that. It's about creating systems that are resilient, adaptable, and easy to understand.
Yeah, exactly. It's about making conscious decisions about what information to expose and what to conceal, not just to manage complexity, but also to enhance flexibility, maintainability, and testability.
All right, I'm feeling pretty pumped about applying these ideas to my own projects. But before we wrap up, let's do a quick recap for our listeners. What are the key takeaways they should keep in mind?
Well, first and foremost, remember that information hiding is about creating boundaries and managing dependencies between different parts of your code. Whether you're working with classes, functions, modules, or even entire system components, the principle remains the same. Control access to information and minimize the ripple effect of changes.
Right. It's like that old saying, loose lips sink ships. Except in this case, it's loose code that sinks software projects.
Exactly. And keep in mind that information hiding isn't just about slapping private labels on everything. It's about making informed decisions about what information truly needs to be hidden and what can be safely exposed.
That's a balancing act.
Absolutely. Overusing information hiding can sometimes lead to overly complex systems where it becomes difficult to understand how all the pieces fit together. It's important to strike the right balance between abstraction and transparency.
Got it. Don't hide everything, just the things that really need to be hidden. Any other parting words of wisdom for our listeners?
Yeah, I'd encourage everyone to explore how information hiding is implemented in their preferred programming language. As we discussed, different languages provide different mechanisms for achieving this. Understanding those nuances will empower you to apply the principle effectively in your own work.
Fantastic advice, and I think that's a perfect note to end on. A huge thank you to you for sharing your expertise on this fascinating topic. I feel like we've only scratched the surface of information hiding, but I'm already seeing how it can be a game changer for writing better, more maintainable code. It's been my pleasure. To all our listeners out there, we hope you've enjoyed this deep dive into information hiding. We encourage you to experiment with these ideas in your own projects and see how they can help you level up your coding skills. Until next time, happy coding.